in the practice problems here, we're asked to do a few different things. First thing says, give the congruence statement and the reason that the triangles are congruent. Then use CPCTC to identify the remaining corresponding parts and values. First part, the congruence statement, is which triangle is congruent to which triangle. And then the reason is why you know they're congruent. So let's start and make sure that they are congruent before we get too far. Now, in these two triangles, we actually have a few different options. Reason we have a few different options here is because we have more than 3 pieces of information. We have a side, and a side that we have in both of them, so we could do side, side, side. We also have some angles in here. Now, I take back what I said because I just realized that these angles are not, in fact, congruent. They are different angles, so we don't have 2 equal angles to work with. So the only thing we do have in common with both of them is side, side, and side. So our reason is going to be side, side, side. Now our congruence statement. Let's pick something on this side. Let's go A, B, C. Let's just nail down our first triangle, because that order doesn't really matter. The important part is making sure that it lines up with the other one. So triangle ABC is congruent to, now here's where we have to be careful. A is at the intersection of side with 1 tick mark and side with 3 tick marks. So the side with 1 tick mark, side with 3 tick marks, the intersection of those is at angle R. So use our triangle symbol to say we're at a triangle, and then R. B is between the 1 and 2 tick marks, so the 1 and the 2 tick marks is going to be our I, and then we have a T. So R, I, T in that order. Last thing it says, use CPCTC to identify the remaining corresponding parts and values. We know the 3 sides are already congruent. They've been marked on our picture. We don't know about which angles are congruent to each other. So we're going to use CPCTC to find the remaining angles. Conveniently, sides or angles are a little bit easier to find than sides. The first letter and the other first letter are going to be equal angles. So if we do angle A, we can say that's equal to angle R. Same thing with the second letters. Angle B equals to angle I, and then angle C and angle T. So that's what it means by using CPCTC. That's the corresponding parts of the congruent triangles are congruent. So all the angles and all the sides of these congruent triangles are congruent. The reason I only did the angles and not the sides is because we already know that this side and this side are congruent, that this side and this side are congruent. They're marked in the picture, so we don't need those to be written again. Second problem says, use a picture below to answer the following questions. What do you need to prove the triangles are congruent by angle, side, angle? We look at our picture and we see that we have an angle and then we have another angle. Angle, side, angle says that you need an angle, a side in between those angles, and then another angle, which means that we need this side, the side in between those angles, in order to prove anything is congruent by angle, side, angle. So what do we still need? We need to know that BC, I'm going to go from the 1 tick mark to the 2, so BC is equal in length to, and go from the 1 tick mark to the 2 again, is equal to EF. So side BC right here, side EF over here, those two need to be equal. Now it says, what do you need to prove the triangle is congruent by AAS? Let me clear this out here. By angle, angle, side. Here we have an angle, here we have an angle. We would need a side. Angle, angle, side. If you're thinking that there might be 2 ways to do this, you're right. We'll get to the second way in just a moment. So we could say that CA, from the double angle to the unmarked one, side CA is equal in length to side FD. That would be one way to do it. However, angle, angle, side, we could also find the side on the other side. So, or we have angle, angle, side. Angle, angle, side. So we could say BA is equal to, and we'll find it in the other one here, BA is equal to ED. So if either of these statements were true, we could prove these triangles congruent by AAS. Let's look at number 3 here. We're asked if these triangles are congruent, and if so, by what reason, and if not, why not? Well, looking at the first picture, I have an angle, and a side. So I'm thinking AAS, angle, angle, side. Let's make sure that that corresponds exactly with what we have in the other triangle. I have the angle with 1 tick mark, okay, followed by the angle with 2 tick marks, alright, followed by the side over here, followed by the angle, angle, side, angle, angle, side. I have my sides in different places. When that happens, when they're not in the right order, when you have a different angle followed by a different angle followed by a side, that does not prove congruence. The angle with 1 tick mark followed by the one with 2 followed by the side needs to be the same order in the other triangle. It can't be swapping around your angles. So we have not proven that these are congruent. We have failed to prove congruence. Side is in a different place. And we could write that. So when they're not in the same order, it does not work. Skip down to number 4. We're asked, first one, what information do you need to prove these triangles congruent by ASA, or angle, side, angle? To do it by angle, side, angle, we need an angle, a side, and an angle all in a row. We look at our top picture. We have an angle, a side, and we would need an angle right here. We have an angle, a side, and we need an angle right there. So the missing link that we don't already have is x and t. We would need angle x to be equal to angle t. Let's clear this out and go ahead and try to repeat this for the second one, angle, angle, side. If we want to do angle, angle, side, I would say the easiest way is to work backwards from our side. We have a side, we have an angle, and then we need to follow it out to another angle. So they're all in a row like that in that order. Same thing here, we have a side, we have an angle, we have to follow that out to another angle. So making sure that the corresponding pieces are in the right order, the double marked angles are the ones in the middle, the marked sides are on the end, so then we just need W and Z to be equal. And then finally this last one here, we have SAS, side, angle, side. And so to do it by SAS, we need a side, which we have, an angle in the middle, and then a side. A side, an angle in the middle, and then a side. So the sides that we don't have are YZ and VW, and those would need to be equal to each other. So YZ would need to be equal to or congruent to VW. Let's move on to number 5. A little bit of a word problem here. We're told that Midtown is exactly halfway between uptown and downtown. So Midtown here is the middle, is exactly halfway between uptown and downtown. And we know when this is the midpoint, that means that this is equal to this. So we can mark those congruency statements on our picture. We're also given these right angles. What is the distance between downtown and Lower East Side? So let's mark that on our picture. We don't know what it is, but we'll have to figure that out. How do you know? Write a few sentences to convince the reader your answer is correct. Whenever you have these pictures, there's a few things you always should be looking for. If there's a side that is shared in a picture like this, always mark it with tick marks on itself to mark it reflexive. We'll look at that later. For now, the thing we do have is vertical angles. Whenever you have this butterfly type picture, you're always thinking, I have vertical angles. Immediately mark that so that you know that those things are equal. That will help you in many different situations. Now, let's look at what we have. We have right angle, right angle. Right angles are equal to each other. So we have angles. We have a side right next door. So we have angle side. And then finally we have two equal angles right across from each other. So in this order we have angle, side, angle, angle, side, angle. We can prove congruence with that. So by ASA we can prove congruence. And let's go ahead and we'll give these points all letters. So we'll call this U, M, L, D, and we'll have to call this maybe W because U is already taken. So we have all our points with names, and if we're going to make a congruency statement with this triangle, we would say something like U, M, W. Let's just make up the first one, it really doesn't matter. Triangle U, M, W is congruent to, and now the order matters for the next one. So triangle, what's going to correspond with U? It's going to be the other right angle, so D. What's going to correspond with M? It's going to be the other equivalent angle, the vertical angles, and it's going to be M again. And then what's going to correspond with W? It's going to be our remaining side, or angle L. So this is by ASA we get this congruency statement right here. Now our real question says distance from downtown to Lower East Side. So let's go ahead and make sure that we know what that is. DL, we want to know DL, so first letter, third letter. That's going to correspond to the side UW. The side UW is right here. So that means these two sides are equivalent, are congruent to each other, and this is 1.5. This is going to be 1.5 kilometers down here as well. And we know that by CPCTC. So the distance, 1.5 kilometers. Write a few sentences. If you could write a nice flow like this, it basically acts as a flow proof, proving what you know, or some other very clear written out proof type of statement, I would accept that as a few sentences. So that is up to you how you choose to phrase your logic, as long as you're clear about what you found.